All right, so let's get into the last lesson for Unit 6. This is going to be 6.2C. So with 6.2, again, we split it into three sections. Okay, the first section we talked about was parallelograms and rectangles. The second was squares and rhombi. And for this last section, we're going to talk only about trapezoids. Okay, and we're going to talk about just a general trapezoid as you see up here in the top, and then a more specific type of trapezoid, an isosceles trapezoid. You might recognize that term isosceles from Unit 5. So let's get straight into it. So just like with the rest of them, they each are going to have a certain number of key characteristics to tell if any four-sided figure can be one of these two. So with trapezoid, makes it real simple. Okay, with the rest of them, they had anywhere from 5 to 10 things we had to check off in order for it to be classified as that figure. But for a trapezoid, there's really only one. For a trapezoid, it can only have exactly one pair of parallel sides. Okay, it has to be exactly one. If it's two pair of parallel sides, then that's going to make it a parallelogram, a rectangle, a square, a rhombus, literally any of the other ones. But a trapezoid is unique because it only has one set of parallel sides. So you see in here, I marked the top and the bottom side with these arrows that are going in the same direction, signifying the top and bottom are parallel. But if we took the left and the right side together and we tried to push them a little bit closer, we would see that eventually they would probably intersect with one another, and therefore they wouldn't be parallel. So this is indeed a trapezoid. And another thing to keep in mind is with this median formula. Now, we need to figure out what is the median in a trapezoid. So we have in a trapezoid, we have two bases. Okay, so this is one base, this top line, and this is another base, this bottom line. Okay, and oftentimes in a trapezoid, we'll call it base 1 and base 2. Well, in order for us to determine what is the length of the median, we need to know the lengths of both of these bases. So this base 1, also known as B1, and this base 2, also known as B2. Well, if I add these two lengths together and take half of them, that's going to give me the length of this line right here, the median. Again, median is another term you might remember from Unit 5, but median in a trapezoid is going to mean a little bit different thing. So a median in a trapezoid is going to be the line that connects the two midpoints of the two non-parallel sides. Okay, so what that means here, you have your top and your bottom, your bases, they're your parallel sides. And so these other two sides, the sides on the left and the right, they are being bisected by the median. And that's really where the median in a trapezoid is going to pop up at. And for us to determine what that median length is going to be, we'll just take half of the sum of the two bases. Okay, so that's for any trapezoid. So now let's get a little bit more, close together with it. Let's look at an isosceles trapezoid. A little bit more refined definition. So an isosceles trapezoid is going to have 5 things, or technically 4, but 5 things we need to note about an isosceles trapezoid. So just like with a regular trapezoid, it's going to have exactly one pair of parallel sides. If it has more than one pair, it can't be a trapezoid. Instead, it's going to have to be a parallelogram or something else. And once again, we can calculate the median by the same formula. So in this figure, they didn't actually draw the median. I assume the median would probably drawn somewhere around, let's say, maybe around there. But in this particular figure, they didn't draw the median, but we would still calculate it the same way, take the sum of the two bases. But then there were 3 other things that they noted. So number 3 was that the legs are congruent. So in an isosceles trapezoid, the legs are going to be the non-parallel sides. So we have the parallel sides, and they're going to be our bases, but the non-parallel sides, they're going to be known as our legs. And these legs are going to be congruent to each other. So you see right here on the side, these are my 2 non-parallel sides, and I mark them each with 1 tick to show that they are equal to one another. Say, number 4, the diagonals are going to be congruent. So the diagonals going from top left to bottom right and top right to bottom left, they are going to be equal. They're not going to be bisected like with a lot of the other ones we've seen so far. As you can see, it seems that we have a shorter piece and a longer piece. So instead, just the whole thing and this whole thing will be equal to each other. So there's 2 ticks on both of them. And then number 5, the base angles are going to be congruent. Now with this one, the base angles. So first we need to identify what is our base. Now our bases in our trapezoids are going to be our parallel sides. So oftentimes it'll be your top and your bottom, although sometimes they may turn it a different way. So your base angles. So there's going to be a little bit, also a little bit counterintuitive what the rest of them have been. Normally we've been saying the opposite angles are congruent, but in this one, the base angles are congruent. And what I mean when I say this, the base angles are going to be the two angles on either one of the bases. Okay, so you got two bases. You got a top base, you got a bottom base. So the two angles on this bottom base are right here in the bottom left corner and right here in the bottom right corner. We're going to ignore that diagonal for right now. Okay. So these two angles are going to have the same measure. Likewise, the two on the top, okay, we have a top base and a bottom base. So the two on the top base means this top left and this top right angle, they are also going to be congruent to one another. So that's going to be the 5 key features of an isosceles trapezoid. Now let's look at a few examples. All right, so example 1. We've got find the value of x. So we're given this figure. It has angle measures of 12x plus 3 degrees, 13x plus 2 degrees, and then we've also got right angles included in here as well. So we need to figure out how to solve for the value of x. Well, if we think back to 6.1, we were talking about the sum of the interior angles. Well, in any four-sided figure, the sum of the interiors was going to equal 360 degrees. And that was for any quadrilateral, and a trapezoid is a quadrilateral. So then if we have these two are equal to 90, so they're going to equal 180 together. So then we know that 180 plus all of this stuff will equal 360. And I'll write this line in right here. So we know that 180, and this is coming from my two right angles, plus 12x plus 3 plus 13x plus 2 is equal to 180. So then we start getting a little bit more simplified. So I can take out that first 180 and I'm left with, not equal to 180. Should be equal to 360. So now we can take this first 180 and we can subtract it from both sides, and we'll be left with 12x plus 3 plus 13x plus 2 is equal to 180. So these two angles will be supplementary to one another. So from there, we go through, combine our like terms. 12x and 13x will give me 25x. 3 and 2 will give me 5. So I've got 25x plus 5 equals 180. Subtract my 5, 25x equals 175. And then divide by 25, and we'll get that x will equal 7. All right, next up, example 2. So in example 2, we're given this trapezoid, and we're told that AB right here has a length of 7y plus 6. EF right here has a length of 5y minus 3. And DC up here has a length of y minus 2. And we're asked to solve for the value of y. Now, in this particular figure, we can kind of assume that EF is going to be our median in this trapezoid. Again, a median can be in any type of trapezoid. And then our bases will be right here. So this will be my base 1, and this will be my base 2. So my median formula up here told me that 1/2 base 1 plus base 2. So that's what I want to do. My median, which for this one, we don't have m, we have 5y minus 3. So median is 5y minus 3. This will be equal to half of base 1, y minus 2, plus base 2, which is 7y plus 6. So with this one, you can distribute the 1/2 first, or you can add the stuff inside first. I'm going to add the stuff inside. So y and 7y gives me 8y. Negative 2 and positive 6 gives me positive 4. So I've got 5y minus 3 equals half of 8y plus 4. Now we can distribute that half and get 5y minus 3 equals 4y plus 2. Subtract 4y and add 3, and we'll get that y is equal to 5. All right, for example 3, so example 3 here, we're told that trapezoid DONE is an isosceles trapezoid, which means that legs are congruent, diagonals are congruent, base angles are congruent. And then one other key thing right here is that Not necessarily that the consecutive angles are going to be supplementary. Let me erase that. But instead, what I mean to say is that in an isosceles trapezoid, what we're going to get is that the left side angles are supplementary. Had a misprint there. Not the consecutive angles supplementary, but instead the left side angles will be supplementary. And on the flip side, that would imply that the right side angles are supplementary as well. They'll both equal 180. So we're given that angle EDO has a length of 110 degrees and angle DEN has a length of 15x minus 5 degrees. So we know that the left side angles D and E can be added together and equal 180. So I'm going to add them together. 15x minus 5 plus 110 equals 180. Combine my like terms here. 15x plus 105 equals 180. Subtract 105, 15x equals 75, and then divide by 5, and x will equal 5. And then lastly, we have example 4. And example 4 says, TRAP is an isosceles trapezoid. If PR equals 3x minus 7 and TA equals 20, find the value of x. Well, PR and TA are diagonals in an isosceles trapezoid. And if we look back up here on our list, number 4 says that the diagonals are congruent. So PR is the length of one whole diagonal. TA is the length of another whole diagonal. So we can set these two equal to each other. 3x minus 7 equals 20. Add my 7, I get 3x equals 27. Divide by 3, and finishing out, I can get x is equal to 9.